Zeno of Elea was a pre-Socratic Greek philosopher from Italy whose impact on philosophy through his paradoxes contributed to the development of logical and mathematical rigor. In his lifetime, Zeno proposed a total of 9 paradoxes: the 3 paradoxes of plurality, 4 paradoxes of motion, the paradox of place, and the paradox of the grain of millet. His paradoxes were specifically targeted towards particular schools of thought, or people, and were regarded as ad hominem. We explored one of Zeno's various paradoxes of motion, specifically the paradox of Achilles and the tortoise, and researched to understand the dilemma Zeno presented thousands of years ago, and applied our own knowledge and understanding of logic and mathematics to explore possible solutions to this paradox.
What is the paradox of Achilles and the tortoise? Achilles and the tortoise is a distinct paradox that presents a dilemma for two objects in motion passing each other. The paradox of Achilles and the tortoise outlines a situation in which a man, Achilles, can never overtake the tortoise in a foot race if he gives it a head start. Zeno argues that in order to pass the tortoise, Achilles must first reach the initial position of the tortoise, which is x1. However, in the time it takes to do so, the tortoise would have also moved on to a new position x2, creating a new distance of x2 minus x1 between itself and Achilles. This continues indefinitely, with each iteration creating a smaller and smaller distance between Achilles and the tortoise, with this converging to 0. Achilles and the tortoise is similar to one of Zeno's earlier paradoxes, the dichotomy paradox. This is because they both present a similar dilemma for motion and are both solved in a similar way. The dichotomy paradox states that before an object can travel a certain distance d, they must travel a distance d divided by 2. This continues indefinitely, and therefore to travel all the way, the object must go through an infinite amount of finite distances, similar to Achilles and the tortoise.
The distance d in meters between Achilles and the tortoise is x minus sa minus st times n. If x is the original distance that the tortoise is ahead of Achilles, n represents how many seconds have passed since the start of the race, sa represents the rate at which Achilles moves during the race, and st represents the rate at which the tortoise moves during the race, then we can infer that the distance between Achilles and the tortoise is dependent on time. If the original distance between Achilles and the tortoise is 0.9 meters, the speed of Achilles is 1 meters a second, and the speed of the tortoise is 0.1 meters a second. Then with every second that passes, Achilles will move 1 meter, whilst the tortoise will have only moved 0.1 meters. This would imply that at n equals 1, Achilles will be toe-to-toe with the tortoise, and at n equals 2, Achilles will be 0.9 meters ahead of the tortoise. However, Zeno's paradox is that in order for Achilles to pass the tortoise, he has to first reach the original position of the tortoise by traveling 0.9 meters. But in the time taken for him to travel that distance, the time being 0.9 seconds, the tortoise will have already moved forwards by 0.09 meters. This pattern continues on infinitely. In each successive instance of n where Achilles reaches the tortoise's position, the tortoise will have moved away in small increments. Thus, the distance between Achilles and the tortoise, d, starts off at x, but converges towards 0 as time tends towards infinity.
Let's take an example. Let's say the tortoise is given a 1 meter head start. Assume that Achilles is 3 times faster than the tortoise. When Achilles travels the 1 meter to where the tortoise has started, the tortoise would have traveled a third of a meter. Thus, by the time Achilles reaches the new position of the tortoise would have traveled another third of that distance, which would be 1/3 times 1/3, which would be 1/9 of a meter. The paradox claims that this will occur infinitely. According to the paradox, if the tortoise is given a head start, Achilles will not be able to catch up to the tortoise, as the tortoise would have already moved on forward every time Achilles reaches the tortoise's previous positions. Now let's try and explain this using some mathematical reasoning. The sum of all the distances the tortoise travels is s is equal to 1 plus 1/3 plus 1/9 plus 1/27 and so on and so forth. Factoring out 1/3 from this gives us s is equal to 1/3 open bracket 3 plus 1 plus 1/9 plus 1/27 so on and so forth close bracket. This is the same as 1/3 open bracket 3 plus s close bracket. And thus is equal to 2s is equal to 3, and we can rearrange that to give us s is equal to 3/2. The tortoise's claim has not been refuted that there are an infinite number of steps. However, although there are an infinite number of steps, Those steps are combined in a finite distance and are also happening in a finite time. Therefore, according to our solution, Achilles will overtake the tortoise in 1.5 meters. Although it will take him an infinite amount of steps to do so, these infinite amount of steps add up to a finite distance, and these steps are occurring, crucially, in a finite time.